Hello. In this video of 6.2, we are going to be focusing more on multiplying, the multiplying side of radicals, so roots. First, when you have the same index, if you have the same index, and then we multiply, you can just multiply those two numbers or group of numbering just right on together, which is awesome. However, if they don't have the same index, you cannot apply that property. Bummer. So this first one, when I look at this, my indexes here are not the same, so I cannot apply that property. So no, I can't do that because the indexes are different. Index different. Now I look at my second one, I have a third root, which by the by, if for some reason you have a, let's say, a negative number here, you have to make sure that this is an odd index. If it's not, then you can't do that. I can multiply those two together. So this would become the third root of negative 8. And I can actually apply the third root of negative 8. The third root of negative 8 would be negative 2. That would be my answer. Bing, bada, boom. And again, 8 is just one of those cubic roots you just have to know. 8, 27, 64, 125. Those are pretty easy ones. Try these by yourself. You should have no different indexes, and the second one would be negative 5 times negative 2 gives you a positive 10. So you still apply that rule, and it's the fifth root, so that's okay since they're negative. And I can't simplify them any further because there's no group of 5 that I could take out. So you should do the simplest form when you have it. And I kind of ended the 6.1 video on something like this if you watched my 6.1 video. But you want to rewrite 128. And so the first thing I would do personally is I would do a factor tree to see what does 128 give me. What are the factors of 128? So factor tree it up. So that's my factor tree. So I'm doing the cubic root, and if I look at this, I have 1, 2, 3, 4, 5, 6, 7. I have 2 raised to the 7th power with x to the 7th. So this would be a little bit easier. So now I want to think, how many groups of 2 can I take out of 2 to the 7th? Well, 6 is a factor of 7. So I can take out 2 groups of 3. So this would be 2 squared. And again, if I multiply those two together, that's actually taking 6 2's out because you're taking 2 groups of 3 out. It's the same concept as with the x's. I can take 2 groups of 3 out of 7. So then what I have left here is 1, 2, and 1, 7. So that right there would be my final answer. And my absolute value does not play a point here. The only time absolute value really matters if you start with the even and you end with the odd. Since I didn't even start with an even here, I'm not even going to worry about it. So here I'm multiplying together. So one thing you can do is I could rewrite this. So this could be the square root of 72 times 10 would give me 720. X cubed times x would give me x to the 4th. And y squared times y cubed would give me y to the 5th. And now this is the same thing. So I would do prime factorization of 720. So I'm going to rewrite this. And I should say again, the reason we could multiply those is because those indexes were the same. They were both 2. If there's no number, it's always a 2 there. It's a square root. So I'm going to rewrite this square root as I have 1, 5. I have 1, 1, come on, 1, 2, 3, 4, 2, so it'll be 2 to the 4th. And I have 1, 2, 3, so 2, 3 squared. I still have my x to the 4th, my y to the 5th. So now, if there's no number, the index is 2, so I'm looking at pairs of 2. Can't do anything with that 5. However, I can take out 2 squared, because I have 2 groups of 2 in this 4. I can take out 1, 3. I can take out 2 x's. I can take out 2 y's. Now, when you're looking at this, what's left over? I didn't do anything with this 5. This 5 has to stay inside. I took out 2 groups of 2. So that was a total of 4 on the inside because it was 2 groups. So 2 times 2 is 4. I took out 1, 3. So 1 times 2. Again, I'm times it by my index to make sure I have everything I counted for. So 2 times 1 is 2. So I took those all out. I took out 2 x's. So 2 times 2 is 4. So those are counted. I took out 2 y's. So 2 times 2 is 4. I took out 4 y's. That means I still have 1 y left over. Now with this one, when I'm doing my square or my absolute value, if you look back at the very original problem, they're all, or this is a square root, they all have to be even. You can't take a square root. I'm asking for real numbers. Here, if it's not asking for real numbers, you should apply real numbers. So if this is a square root, that means these numbers have to be positive. So this right here would be my final answer, or I could actually still multiply these together. 2 squared is 4, and 4 times 3 is 12. So this would be 12, x squared, y squared, square root of 5y. Final answer. You should try to do this next one by yourself and see what you get. Final answer, 15x cubed, y cubed, square root of 7y. Now, when you want to check your work, you want to make sure, did I do that right? You look at your index, and you look back at this. If you want to check your work from here to here to make sure you have everything accounted for. If my no number, it's a 2. So I'm going to take whatever's on I took out. So 1 times 2, that should represent what was on the inside. So I did have 2 3's on the inside. 1 times 2, that was a 2 on the inside, so I'm good. 3 times 2, that was a 6 on the inside, so that's good. 3 times 2, that's a 6. That means I have 1 left over, so I should have 1 left inside, so that works. So then I just multiply the 3 times 5, I got 15, bing, bada, boom, there you go, multiplying radicals, life is great, life is grand. Have a good day.